In this video, we're going to compute the mean for the normal distribution. Okay, our random variable has the probability density function given by 1 over sigma times the square root of 2 pi times e to minus x minus mu squared over 2 sigma squared. Okay, here we have the probability density function. We're also gonna accept this one here. We don't want to prove it here. There are many ways to prove it, but we're gonna accept that the integral of e to minus x squared between minus infinity and plus infinity is the square root of pi. Okay, we can prove this one later. Okay, but for now we just accept it because we're gonna use it here. Now we can use the definition of the mean. Okay, let's call it a. So it's gonna be the integral between minus infinity and plus infinity of x f of x dx. Now we have the probability density function, we have this integral, we have the definition. You can work this one out if you want to do it by yourself and find the mean. Okay, you can stop here and start working out this problem by yourself. Okay, otherwise let's continue. Okay, here we can write this one as the integral between minus infinity and plus infinity. Here we have f. It's 1 over sigma square root of 2 pi e to minus x minus mu squared over 2 sigma squared dx. We're gonna simplify this expression. We will introduce a new variable. Okay, let's call it y. So in fact, we're gonna use y as x minus mu over square root of 2 sigma. Okay, when I use it here, that's why I had to use the square root, because when I square, I'm gonna get rid of the square root and I have sigma squared. Here, I have y and I need dx. Dx is gonna be square root of 2 times sigma dy. The bound won't change. Okay, and here I think I missed x. I need x here, and x is gonna be square root of 2 sigma times y plus mu. Okay, having all this information, we can proceed now. So I'll take this one here outside, the constant 1 over sigma square root of 2 pi, the integral between minus infinity and plus infinity of x is square root of 2 sigma y plus mu e minus y squared dy. So here I need to have square root of 2 times sigma. Okay, so I'm gonna move them to the front because they come with dy. So I'm gonna put them here, square root of 2 sigma. Now my expression, it's gonna be 1 over square root of pi, the integral between minus infinity and plus infinity, square root of 2 sigma y plus mu e minus y squared dy. Okay, now I can use the definition of the improper integral to find my result. These two integrals, I'm assuming that the integral of e y squared and e to minus y squared, both of them convergent. Okay, I can split this integral. I have 1 over square root of pi, the integral between minus infinity and plus infinity. I'll take this one outside, square root of 2 sigma, and I have the integral between minus infinity of y a y squared dy plus 1 over square root of pi, the integral between minus infinity and plus infinity mu e minus y squared dy. Okay, now for this one, I can, this is a first kind improper integral. I can apply the definition and compute it, but I can see clearly that this function here is odd. Therefore, this integral is 0. So I'm left with this one here. Okay, so here I have 1 over square root of pi, the integral between minus infinity and plus infinity of, I'll take the mu outside, mu e minus y squared dy. I have one more step to conclude, which is using this fact here, that the integral between minus infinity and plus infinity of e minus x squared dx is square root of pi. Here, the only difference I have is instead of x, I have y. And therefore, this is square root of pi. So once I do that, I have mu over square root of pi times the square root of pi. And therefore, I have a that I started with, which is the mean. A is equal to mu. Okay? This proved that the mean for my random variable, normal random variable, is given by mu. Okay, that's why we say that the mean, okay, the mean is equal to mu. And this is why when you have a normal distribution, you can read the mean from the probability density function if you have it. Okay, like here I can read this is minus the mean. This is my mean mu. Okay, this is the proof of the mean. We're gonna compute the standard deviation. Okay, using this fact here and using this expression here for the improper integral. Okay, thank you very much.